Hi, this is Jeff Rowe with MCAD Café, and I am at HxGN-Live 2017 this week in Las Vegas. And joining me this afternoon is Arjaan Buijk of Hexagon. Thank you very much for joining us.
Oh, hi, how are you doing? Very welcome to be with you.
Now, before we get started on what we're going to really discuss here, can you talk a little, you're with MSC Software.
Yes, that's right.
And can you talk a little bit about the acquisition?
Yes, yeah. So I'm with MSC Software, and we were recently acquired by Hexagon. And one of the things that we're doing at MSC Software is simulation, fine element simulation. And one of the areas I personally work in is in the area of manufacturing simulation and validation. Okay. And that's why it fits really, really well in the overall Hexagon portfolio.
Okay. Okay. It's really going to become a major part of their digital thread and manufacturing intelligence.
Yes, definitely. So if you look at how you go from concept to product, you have this digital thread where you go from MCAD design to your manufacturing process design, and then instead of going straight to physical prototyping, that's the place where you want to do some simulation first to check if your manufacturing process is working well, and then you iterate there to optimize it, and then you go on and just try to build things right the first time and not go and iterate it, and that's the value that you get out of doing manufacturing type simulation.
Okay. Now, can we talk a little more specifically about Simufact and how it can handle both metals and composites?
Yeah. So the Simufact is actually the brand that focuses on metals, and Digimet, that's another brand from MSC Software that focuses on the polymers and composites. Okay. But you should think of both products in the manufacturing space as basically doing the same thing, but then for different type of materials. Okay. And one thing that we're really highlighting here at the show this week is our capability for additive manufacturing.
Yeah, that's huge.
That's such a huge upcoming field with a lot of interest, and that's exactly one of the areas where people they spend so much time on trying to build these parts correctly, where simulation can just help so much. Okay. Yeah.
Okay. Now, do they differ substantially? I mean, like the user interface or the workflow, does it differ? Depending on whether it's metal or composite.
Yeah. Basically the way you run the simulations, the workflow is very similar. It's almost more historically that you have just two separate brands and two separate products, because before additive manufacturing at Simufact we were doing metal forming simulation, like forging simulation, welding simulation, joining simulation, and that led to adding a additive manufacturing capability for metal. And the same thing on the polymers and the composite side, on the plastic side. Okay. The Digimet company for years has been doing material characterization, because on the polymer side, what's very important, you're almost designing the material, right? You have the filler material, you have the resin that you have, and then to be able to take that information, and they call it homogenization, to convert that into material data that you can use in finite element simulation. That's a real strength of the Digimet product. So they created this whole environment where you do that type of things to drive more traditional plastics part simulation, and it was very natural to plug an additive manufacturing capability for plastics in that environment. Okay. So it's all there for the plastics material engineer. For the metal side, there's the one that speaks the language of the metallurgist or the metal additive manufacturing engineer. Okay. So,
well, the additive manufacturing aspect is huge.
Yeah. So I can talk a little bit more about the why people really want to do simulations. That's probably of interest, because when you have a part and you additively manufacture it. You want to have a part that has a certain shape, and you want to come out straight like that. Yeah. Well, what happens, especially with metals, if you build up the part, you're literally melting the material, and then it solidifies. And when that happens, it shrinks. So the way you build it, it's never going to come out straight. It's always going to come out a little bit crooked or an angle. And instead of trying to figure out by trial and error on the machine,
Okay.
to say, well, I need to build it in this direction, and then when I remove it, it comes out straight. Or if you design support structures to avoid that it doesn't break or collapse on itself, do those things on a computer, and you just save a lot of money.
Okay.
That's why people like the software.
Okay,
Yeah.
excellent. So now, where can our viewers go for more information about all of this?
Okay. Well, you can start at several locations. Start at MSC Software website. That's one location. Also, Simufact has its own website, simufact.com. If you go there, you'll find everything about the metal forming and additive manufacturing for metals. And digimet.com for the plastic side. That's that's the best spot. And then from there, you can look at it, study it, and if you want to reach out to us, there's contact us right there. So.
Okay, excellent. Well, Arjaan, thank you very much for joining me today.
My pleasure. Thank you very much.